Hello, everyone. My name is Ujjwal. I'm a principal machine learning for healthcare and life sciences SA here at AWS. And today I'm here to talk about Amazon HealthLake. Amazon HealthLake is a HIPAA eligible service that allows you to store, transform, and query healthcare information to create a longitudinal view of a patient that then you can start using for a variety of analytics and machine learning use cases using AWS services. So let's look at what HealthLake is. I'm going to walk you through a simple demonstration that shows an end-to-end life cycle of building an analytics application. And hopefully by the end of the session today, you have a fair sense of how to utilize HealthLake for your own business problems in the healthcare space. So let's get started. So what I'm showing you right now is the console view of Amazon HealthLake. So when you go log in into the healthcare AWS console, you basically just navigate to the healthcare HealthLake homepage, and this is where you end up. What HealthLake does as the first thing is allows you to get all your FHIR records into a centralized data store. Now, to do that, you would want to create a FHIR data store within HealthLake. To do that, you would go to on the left-hand side, you would see data stores. So you can just click there. And the first thing you do is actually create a data store. When you start creating a data store, it will ask you for some parameters. So the first thing you provide is the name of your data store. There are some restrictions on how you can name them. But this gives you an identifier for your data store that you can start like referencing to for your downstream use cases. One thing to note over here is all these parameters that I'm showing you right now is being provided through the AWS console, but they are also available through APIs. So you can easily go to, the AWS SDK and depending on the choice of your language, you would find APIs that are specific to the actions that I'm showing you through the consoles today. The other thing to note is the creation of the data store is also an operation that you can provide or create via AWS CloudFormation, which is a great solution for anyone who's looking to automate the creation process during the deployment of an application, for example. So here you can see like the data store expects you to provide it a name. The format right now is dependent on FHIR R4. So you need to have FHIR compliant data sets to be ingested into the HealthLake data store. Now, for you to get started with this really quickly, we have given you an option to load some sample data or synthetic sample data generated using Cynthia. This is a great mechanism if you want to just take the HealthLake data store for a test drive. You don't really have to, ingest real-world patient data to get an understanding of how the service works. And it sets up, a sample of synthetic data sets, loads it up for you to query and search through. Uh, Now, this is a HIPAA eligible service and encryption is built into it. So by providing you the option of getting an encryption key from KMS or an AWS owned encryption key, which is a default mechanism, it allows you to store the data encrypted and making sure that it's secure and safe to store PHI in. So once you've provided all of that, you just click on the create data store option, and that starts the process of creation of the data store. For the purposes of this demo today, I don't want to go through the whole process of waiting. So I have created a data store before the demonstration, and once it's ready, this is what you see. Now, once you have the data store available, you can do a variety of things. So you can, import more data into it. You can export out of it, or you can run a query, which is a common operation that customers want to do. To run a query, again, this is something that you can do via APIs, but just to demonstrate through the console is fairly easy. You just select the query type. So you have options of searching, you can do create, read, update, or delete. So let's look at how the search operation works. So I'm just going to choose a resource. So let's say I choose patient. I search on a parameter. So let's say I want to search on gender and the value I give is female. And I just run the query. This gives me the Fire R4 representation of my patient resource. This is a resource that is again, coming directly from the Fire schema, and you can see like it gives you records back in a JSON interface that has a structure that you can easily load up for downstream analysis. Now, one of the things that HealthLake does during the ingestion process is apply machine learning to extract clinical information or entities from unstructured portions of your medical records. And the way it does that is by utilizing the document reference resource. So, for example, if I just choose, let's say, a resource type to document reference, this is a resource that stores all your unstructured information. So these could be clinical notes, these could be discharge summaries, radiology reports, like anything that doesn't form in the rows and columns construct can be stored as a document reference resource. And HealthLake during the ingestion process extract information from the document reference resource and makes it available for search and query. So let's say I have a clinical note. I do not know what it contains. I just know that it's a blurb of text. Once it goes through the process of ingestion into HealthLake, I can start searching for important information. So let's say I want to search for ICD-10 codes that are in my clinical note. And let's pick a value of F40.1. This is ICD-10 code related to mental health. And I want to look at, what are my clinical notes that actually contain anything related to this that I can just start deriving. And you can see like there are some concepts that are automatically extracted from HealthLake. These are, by the way, not entities that you have manually annotated and extracted ICD-10 codes from. These are literally just ingestions of clinical note that HealthLake actually went through indexing and creating a portfolio of different available ICD-10 codes that you can immediately start searching and querying. So it saves a lot of manual effort for your clinical annotators to look at these codes, understand what type of clinical notes would be important for your downstream analysis, as these are already available, and make those searchable and queryable through the interface of HealthLake or any other downstream um, application or solution that you build on top of HealthLake. Now, one of the common things that you would want to do when you have data already available in this format is to understand how it behaves with other downstream services that support analytics. And one of the common ones is Athena. So customers generally try to use HealthLake and create analytical dashboards out of it. And Athena is a great mechanism to run ad hoc queries on data that is stored in HealthLake. So next, I'm going to switch my tabs and show you how Athena looks when it interacts with data. All right, so now that we are in the Athena console, you can see that Athena console directly interfaces with data that's stored on S3, which is the export location for HealthLake. And you basically get a HealthLake database with all of the different um, files that are extracted from HealthLake as individual tables that are created for you in the catalog. What you can also do is join these tables and create like views if you'd like. So one of the things that we have done here is join the encounter and patient condition resources and created condition patient encounter. Let's look at how this uh, data let's sample this data and let's see how it looks. So here you can see that I have the patient ID, I have all of the individual attributes related to their encounter and some dates. Now, this is a great mechanism for you to create cross-resource analysis. You can, expose these Athena queries into different services downstream for machine learning and analytics, which is exactly what we're going to do in the next section of the demonstration, which is showing you how these Athena tables can be visualized using QuickSight with just a sample dashboard. So I'm going to switch my tabs again and show you how that looks. Okay, great. So now we are in the QuickSight console, and you can see that I have created a dashboard. This is something that's entirely created using the data that is stored in HealthLake and the database that was created in Athena. And you can see like I have created some analysis, so I can find the trends in my patient count by gender. I can do a split, find some charts, and look at different cross-sectional views of my data. This is great for like conventional analytics, dashboards that you would want to maintain. And anytime new data comes out of HealthLake, you can easily refresh these on a schedule or based on a trigger. You can also do a lot with HealthLake in terms of the unstructured information that's already stored in the document reference resource. So here, it's just a simple comparison of pivot table, for example, and it starts using standard conditions that is stored in my encounter and condition table. But if you look at some of the parsed conditions, like these are things that are not readily available in my data sets and are now available and can be seen in my QuickSight dashboard because of that automatic parsing that HealthLake was able to do. So this is a great mechanism for you to extend your analytical use case with extra attributes, extra information to get a well-rounded view of your patient. This is something that you can, do without a lot of effort from a HealthLake perspective, because you're just literally just extracting information that is already ingested and indexed by HealthLake, instead of creating your own machine learning models or own solutions to pass all this unstructured data. Beyond this, you have the option of using this analysis and going into different machine learning based use cases as well. So once you have all of this data available and indexed, you can use the features of these indexes to create new machine learning models. In fact, as a part of the launch of HealthLake, we have created some examples of how this can be done with Amazon SageMaker, which is one of our machine learning services that interacts with data that's stored in HealthLake and creates far better models than what it used to create with just the structured data available um, without HealthLake. So by using all of these unstructured features, you have much more information that the models can learn from, and hence perform better in standard use cases like mortality risk prediction or risk stratification, disease progression analysis, and so on. So that was the demonstration of HealthLake. I hope you got an understanding of how the service works, what are some of the key features. We are coming up with a lot of new enhancements to the service over the course of the next few months. So do watch out for the latest updates around HealthLake. And until then, I hope you enjoy building with HealthLake. So do utilize the service and give us all the feedback. Thank you.